And we've had 4 students from Lab of Future who went on to be interns at Space Copies. And welcome everybody that's taken time out of your busy schedules to be part of today's discussion. It's an honor to be able to meet all of you and have a really great open discussion about space and 3D printing and answer some of your questions. I'd like to start off with sharing a presentation so that you can learn more about 3D printing. And I'll talk for a little while, and then I encourage all of you to write down your questions into the chat box, and I will try to answer as many of them as possible. 3D printing, and that's what we're going to spend our time today talking about here, is 3D printing technology. So if you're not familiar with the term additive manufacturing, it's the exact same as 3D printing, and we'll be using those terms interchangeably today. So if you hear me say the words additive manufacturing, you can think of the words 3D printing. It's the exact same thing. So, additive manufacturing, also known as 3D printing, is the method of creating 3-dimensional objects from a digital file using feedstock. Now we're going to talk about a more complex type of 3D printing, is where we start to implement it into aerospace. So we're going to talk about something called ISM, or in-space manufacturing. So in-space manufacturing is the process of creating mission-critical supplies, infrastructure, medicine, robotics, and so much more to help support astronaut missions in orbit and on planetary surfaces outside of Earth. So whether that's the moon or Mars, if you're a visionary and you're thinking far into the future for manufacturing on Mars and creating astronaut habitats, the only way you can do that is through the ISM process. I want you to go to the chat box and I want you to make your best guess. How much do you think it costs to send 1 kilogram of supplies from Earth to the moon? I see 2, 2.5, 5 million, 30 million. All right, I'm going to give you guys a few more seconds. Some people say 5,000, some people say 1 million, 9 million. I think you guys are really awesome for coming up with so many different numbers. Okay, I'm going to tell you, all right? The answer is 1.2 million US dollars.
So hi, Ms. Feehan. I'm Ayana and I'm 11 years old, and I've been really inspired by your journey, as I too want to work at NASA as a space scientist when I grew up. And meeting someone who's actually worked at NASA has actually meant a lot to me. So I have 2 questions for you. So was there any mission or proposal you received at NASA that made you think this could actually change everything? And also, with the goal of reaching Space Copies 3D printer in space, where we have to work with low gravity and no atmosphere, how do you control the layering process to make sure structures don't warp or misform during printing?
Wow, those are 2 fantastic questions. Wow, I don't know how you guys come up with all this. Okay, I will answer both those questions. So when I was working for NASA, I saw hundreds of different projects. I don't even know if I could pick my favorite one. But something that I saw that I thought was really interesting when I was working in heliophysics, so the study for the sun, they were inventing this new satellite that was supposed to go to the sun, and it was supposed to take thermal images, and it was supposed to analyze when there were expected to be solar flares. So solar flares happen a few times per year. They are completely random. We can't predict them. And sometimes when there are kind of more severe solar flares, it impacts the ability of our GPS systems and our satellite navigation in space, right? So if those solar flares reach Earth, that radiation exposure gets to our satellites and it can take down telecommunication systems for minutes or hours or even days. So we were inventing this new satellite that was going to go around the sun. It was going to offer us prediction up to 6 months in advance before one of these solar flare incidents was going to occur, so that we could position satellites in places away from where that solar flare would emit. So that would prevent us from having, Wi-Fi breakdowns or telecommunication breakdowns from across the world. So when I saw that piece of technology, I thought that is so cool, and it's definitely going to change the game. And to answer your second question about the layering for 3D printing and kind of the microgravity or even the reduced gravity of the moon, because the moon is 1/6 gravity of Earth, and then of course anywhere else in space is completely microgravity. There's nothing. So what we did is we took the standard 3D printer and we put it inside a vacuum chamber, and we created a bit of like an artificial gravity, if you will. So we have a vacuum system that's essentially sucking the 3D printed filament or the powder down to the bottom of the build plate.
So my question for you is, what is the importance of understanding the grain size and the density of lunar dust when designing tools for the moon? And if we ignore this kind of data, what could happen possibly?
That's a great question. We cannot ignore this data. It's just fundamental to the aspect of building in space. The way that we are looking at it right now is we're looking at particle size and morphology, and we're mainly looking at different factors related to particle angularity, cohesion, and different mechanical and geotechnical properties.
So, Mom, I wanted to ask you, how hard are the 3D prints for the space?
How hard are they?
Yes.
So how hard are they? That's a good question. I think it varies on what you're trying to create. But if you think of this like cement, because I like to think of 3D printing with the lunar soils kind of like cement. And if you're 3D printing with scrap metal from space debris like satellites, it's obviously hard like metal.
Hello, Madison. I'm honored because of your work. I have a question that what if the 3D printer gets damaged in the space? Then what would happen? You wouldn't be able to take the picture of it, and plus you can't go near the sun to get it because it will be too hot. So what will you do?
It's a great question. So we're sending the 3D printer to things like the International Space Station, and then we're putting it on satellites to the cislunar space, so about halfway to the moon, and then we're putting them on the moon. And eventually we want to put them on Mars. Ideally, it would be awesome if we had astronauts on site, but that's not a guarantee. If there are no astronauts around and say a meteor hits the 3D printer and something breaks down, we have what we call triage, wherein certain parts of the system can shut itself down, and then we work with whatever is still remaining.
My question is, can the actual printer survive in space? Because the temperatures, for example, a Mercury, one side is 800 degrees and one side is negative 800 degrees. Can it survive the temperature and the pressure and the debris and the rocks in space? Because if the printer itself can't survive, what's the point in the actual material surviving?
That's a great question. And yes, it can absolutely survive, but it's not easy. The 3D printer itself, I talked about some of the different space environment factors that we have to be on the lookout for. So space-based radiation, what we call thermal gradient extremes, so the different temperatures of space between especially the lunar day and the lunar night can be negative 180 degrees Celsius. It could be positive 100 degrees Celsius.
I think we will bid adieu to everyone. Thank you all for joining this. Everyone is joining in from different schedules, so we respect everyone's time. And thank you, Madison, for taking out time from extremely busy schedule. It is very difficult to catch, when you are almost on travel all the time. And I'm really grateful and thankful for you to take out this time for all the students who have joined today.
Thank you very much. And it's an absolute pleasure to meet all of you. Congratulations, all of you guys, for the work that you're doing with Lab of Future and being part of the summer camp. And we've had 4 students from Lab of Future who went on to be interns at Space Copies. So there's always opportunities as you guys can continue to learn and grow. So do stay in touch, and it's an honor to meet you guys. I hope to speak with you guys again sometime.